Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Welcome back to the Grid Mod Pod. Today, we're going to dig into really the structural foundation of grid modernization. Because while we often hear right now all about the digital tools, AI, and distributed technologies, none of it matters, right? If infrastructure underneath can't hold up. So the reality is the utilities are continuously being measured against a series of metrics. So I think I am excited to jump in with Ben, who I will allow him to introduce himself, that works for Osmose, that kind of their foundation has been in the core building blocks of our physical grid. So we will be throwing some metrics at you today, and I think it's a core part of where we need to go. But if you think about it, if you're a utility leader or wanting to make a change, these numbers or these metrics aren't just statistics, they're our scorecard. And so you really can't fix something that you don't understand is broken. So behind every improvement really is, where does the physical grid and the essence of reliability start? And then another word, which I think we'll hit on, is resiliency. So with that, Ben, let's round this conversation. Kind of share your role at Osmose, and then also how does your work contribute to this landscape of grid modernization?
Yeah, thanks for that intro and review of the state of our industry as relates to our assets and infrastructure. So yeah, quick background about myself and the company. So as you said, Osmose comes from osmosis, and it originally was treating wood way back in, 90 years ago, where we got our start. And now we are really the life extension company, right? The life extension company of assets. And what makes us unique is we have millions of data points. You name the asset, and most likely we have not only the condition data, but we also have the data, that performance data. So how did it perform? And our experience is really having the technology and process to diagnose the asset, to identify and understand. We have the expertise to understand the degradation mechanisms of those assets, and then to capitalize life extension solutions that utilities, the options that utilities can use to upgrade their grid, instead of using O&M, to use capital to upgrade to extend the life. So really that's our mission, and that's the space that we live in. However, we're really big proponent of resilience as a whole. And resilience really is a big topic. It's life extension, I think, incorporates resilience. And my background, starting back at the University of Connecticut, I was schooled by director of installation research there. We developed technology to inspect underground lines, and I've rolled that into developing economic models, life extension models for utilities on all kinds of assets. And then more recently, working with, say, Power Delivery Intelligence Initiative, a nonprofit promoting best practices in T&D grid investment. Also a member of, say, WIRES and a couple other organizations. I'm an editor of a couple magazines, trade rags in our industry, Power Systems Technology magazine, and also Transformer Technology, and one more, Women in Power. So I have my ears to the ground. I'm excited about what's happening in the industry. But as you pointed out, it's not just all about the digital space. We also have physical things, physical poles, physical cables, wires that we need to maintain, extend the life, and make sure that they're going to last. Otherwise, we're not going to be able to afford this marvelous grid.
So the grounded, osmosis, and then really your background came to be is like its legacy is in the structural asset management, especially around pole inspection and reinforcement. But as the industry is shifting, towards this space of resiliency, also, or one could say, AKA reliability, or the emergence and or adoption of new technologies that are becoming rapidly more efficient and easily or more easily integratable, because we are innovative spirits at a whole. So we have a whole set of technologies that allow us to change how we used to do things into this new reality. All that. So how has really thinking of your partnerships and the activities that you all spoke of intersected from that traditional to the transformation? Like, if wood pole inspection was foundational, right? You like,
Right.
where are you headed with this type of
Right.
approach?
So we started at wood poles and we moved to, as I said, other structures such as steel towers and concrete structures and substations. And then our customers started asking us, hey, can you also help us with underground components like vaults and transformers and underground cables, medium and high voltage, and also stray voltage issues, low voltage cable system issues. So we have continued to go where our clients have asked us and where the industry has needs to extend the life of those assets. And what we're using from a technology space standpoint is we're using AI in the area of poles. So we have all this data. So if you upgrade a pole, what kind of winds could it withstand? So maybe in its original state, it's only designed for a certain wind speed. Well, if with a couple of capital upgrades, you can bring it up to 120, 30, 40 mile an hour capability. And then we have the data behind those storms when utilities have a category 4 hurricane. We go back and look at those poles to see how do they survive. So that we have an incredibly data rich data set, and we're passionate about helping utilities get access to that data so they can make better decisions. The same thing is with underground. So underground cables, we have the technology to scan those lines, find microscopic defects before they fail. We have actually used AI to inspect those lines, inspect that data, and come up with the recommendations. And from there, our clients are able to make individual repairs instead of replacements and extend the life of these assets. So it's a reoccurring theme of what we're doing with the data. And I think that's one of the most exciting things about our industry is that for a long time, we've had to just wait until things break. And with the ability to use machine learning, now AI, to crunch large data sets and with lots of inputs, we're able to do a lot more predictive analysis on those lines with not only including the pole inspection, but the drones inspection, not only overhead drones, but underground drones that fly down in manholes and take scans of the manhole and do infrared and visual inspections instead of humans doing that.
So I love it. So you said a lot of words. So like grid modernization, it's a term. And I talk about this a lot on this podcast. We are beings that communicate through language where we choose our words, we attach meaning, background, perspective, and really forethought of like where that's headed. So I find, the definition of grid modernization could be quite different to a lot of entities based on the maturity or the space that they're sitting in. But fundamentally or foundationally is, there is this breadth of physical assets that are now inherited and or operated by a set of companies, businesses. But what makes a company or business is actually the people and the processes they execute on. And so I think we lose sight of this bigger phenomena that's occurring is like, we have all of these physical assets that have been here for 100 years or the known essence of how they're connected and work and operate. So there's this tribal knowledge. However, due to the increased demand of our customers' expectations on reliability, which is by definition, and I think this is a fun, topic. If you go into a room full of asset management experts, which I had the opportunity to do in Chicago a few months ago, everyone somewhat has their definition of reliability. Now we are fundamentally as an industry grounded on the metric, which is the terms SAIDI, SAFE, and CAIDI, which were created back in, I think, like they started around the 80s and 90s, I believe, and formulated.
Before me.
Yeah. So they've always been around for those that working in the industry. We've always been grounded in that is how the utility is measured. That is how the consumer advocacy groups assess the utility's performance. That is how the commissioners and the regulators assess the utility's performance. And those quantities are pieces of data that were available at the time which
Right.
wasn't very granular. And we had to make a lot of broad brush assumptions
Right.
to really quantify average outage duration,
That's the key
average
word.
outage
They're all
frequency.
averages.
Yeah, all average restoration time. And so if
Right.
you're in it, right? Like, and you, like at Osmosis, you're inspecting these pools, you're seeing these like varying degrees of failure. We're just picking pools for an example. There's a lot of additional data and additional variables that play into specific spaces of where these assets are sitting, geographical, traffic, weather, right? Like, and so now what you're saying is, you guys have evolved and seen over time, your customers needed polls. They need to be hardened. They need to be validated. But then it started, a lot of questions started being asked, like, well, why are these rapidly decaying and why do we need to go over here? And I guess this is just for the listeners, not for you and I. I think it's a really misunderstood unawareness that here comes people inside a business, which is a utility, and thinking about the span of a 2-county utility. You have a couple thousands miles of distribution circuits, which is then what, 150, 300,000 poles potentially based on the geographical space. And someone's job is to have this full array of assets at their table and needing to analyze and understand the prioritization of like when to go maintain it, inspect it, replace it.
Right.
And the only way you could quantify it was based on these metrics that were created on these base averages. So what
these averages that typically subtracted out extreme events, right?
Right. Which then comes the question of suddenly this phenomena of resiliency, right, became the buzzword.
That's it. Mm-hmm.
So like in this room of asset management experts, I thought it was interesting, like a lot of folks like resiliency and reliability, and actually happened in DC when we were together by our friend Mike Beeler, is like the definitions between the two are actually thought of differently. And we don't have this national or even global grounding of resiliency metrics.
Right.
But like just for our listeners, like my definition, you can correct me, is reliability is the ability of the electric grid to consistently or without interruption under normal operating conditions. So it's like you more or less do projects or assess your system so the failures do not occur. Where resiliency is more about, are you implementing systems and or designs that if a problem does occur outside one's human control, how fast can you come back? And I've learned that might not be the definition that is always taken. So I was just curious, like, what's your definition?
Yeah, I was just at Wires and I was listening to Dr. Chris Beck. I think it's EIS that his organization is involved with. And he's counted 5 different industry-wide definitions of resilience. I asked, can I learn what those are? But my definition is very similar. Right now, my definition is the ability to withstand a high-impact, low-probability event with little or no restoration time. So can you get back up and going once you get hit really hard?
Which is extreme weather, cyber attacks, or
exactly right. And one of the gentlemen on the panel I was just listening to here at the Wires conference, and he was saying that he's a former executive at Dominion Energy, and he was saying he asked his team to start looking at just anomalies. When did you hit the, not just N-1, 2, when did you hit these scenarios where your grid was very vulnerable for strange reasons, and start documenting them? Because not only do we have assets that are aging, not only do we have individuals installing the new pieces of the grid in risky areas like flood zones, like fire zones, like close along the coast. For example, I think 30% of the US population lives within the first county of the coast, right? So we are living in high risk areas. We're counting on the grid more for more of our life. All of our state resources and even federal resources, at least in recent history, has been pushing us to go electric on the grid, to rely on the grid more. So in bits and pieces, we're adding, say, renewables, which are great. Everybody loves clean air. However, we know that they're not dispatchable. So we have generation that's not consistent when on demand. So we've got a lot of challenges that we're adding to a grid, which I think in some ways we've been lulled to sleep. We have a lot of margin. We built these systems very strong to withstand incredible stresses, but we're taking away some of that margin bit by bit, unbeknownst to us. And our operators are starting to see anomalies they've never seen, strange harmonics and strange events where they're getting really close to, on a blue sky day, really close to a resilience scenario. And so one of the ideas that came up in this conference, not only measure the impact when something happens, but can we start measuring the near misses, like understanding, like we do with safety culture, when we get close to having a resilience issue, like the grid trips, are we documenting that and communicating those lessons learned? And the same thing with Osmose, we want to start communicating. Do you realize how close you're in a fire zone? Some of these poles are so close to falling over that if you had this kind of event, you're cooked. But is that information understood? And is there a way to not only quantify to the public? Because I think if the public knew that the next windstorm, it's difficult to predict these things, but if they knew that the high probability, the next 80-mile-an-hour windstorm we have, I'm going to be out of power, and because it's so dry, it might start a fire, I might be interested in spending a little money, ratepayer money, to fix that, right? So I heard the FERC commissioner, Judy Chang, say, we need to communicate the value of these upgrades that we're doing to the grid to our ratepayers. And I hear people saying, well, we try that and they don't understand what we're saying. And so we have a human communication issue. And it all comes back to the point you were making. If we don't have a definition and we're not measuring the resilience or the reliability we have been, the average reliability, but the resilience and perhaps even the near misses, we can't communicate how close we are to a catastrophe to the public. And so it's really, I think, our own fault that we're not able to communicate these complex ideas to people who are not in our industry, who ultimately need to pay for this, because it's a societal product. This is a societal challenge, and it needs to be a societal decision. Without communication, we're not going to get there.
I mean, we're opening a whole can of worms, but at some point in time, a societal decision is important. But at the core of a decision being made is trust. And so if you think about like the problem that we just defined, I mean, this is semantics and language.
It is.
And for those that are like the asset managers, planners, and field operation folk that see it day in and day out of like what is happening versus what is not happening, it's quite maddening. And to have the capacity, the space, and the capability to create the story to champion on a national level becomes very challenging. But hey, we got a grid mod pod to help maybe get some of this language
out.
Well,
that's right. So, we've got to be talking about it.
The problem, like what we're hearing, is in the utility space, when reliability and resilience, come up into a topic. If you talk to the operational folk of the utility, one would say, if we enhance and do the effort that we've understood to make the system more reliable, it will become resilient. So they get lost in the semantics. But all that to say is there's these metrics that are clearly tied to a monetary value. And so it's a disconnection between operational performance and financial decision making.
Right.
So we prioritize our investments by justifying the funding to be able to do any of this cross-functional effort. So I think the power of grid modernization and the story of it is, we're all in this headspace of digital twins, AI, advancing communication, having full situational awareness to create space for this new reality. But I think the missing storytelling is that all of the effort, and aka Osmose is kind of getting into it because, they've been driven by the utilities as the customers say, we need more insight. So what's preventing action is executives and regulators speak in dollars, not minutes or outages, right? It kind of get lost in the layers of information. And the managers and the operators and the planners are actively always asking how to save money, right? But sometimes it's hard to quantify the saving of money, if, as you said, the FERC commissioner said, is like, if we don't have the right set of values, I mean, I don't know, like, is it really a metric? Can we put numbers on everything? And so,
I don't think we're going to fix it if we can't measure it. So,
right. So, like, do we need a resiliency metric, or do we need to enhance and or open the book on these reliability metrics that have been in our world for 40 years, knowing we now have this vast amount of data becoming available? And then we really, nothing really will move until that's finished. But how do we create that space of trust that these performance metrics maybe need to be reassessed based on all the intelligence of companies like yourself? You're sending out sensors, you have the LiDAR, we have the drones. So there's an enormous amount of information that you're quantifying, and we're providing that to utilities, but then now they have it, but if they can't tie it to something that, as we said, they're kind of
to
now
go get
stuck
funding, you need to
without any
communicate
action.
value.
What?
To go get funding, we need to communicate value. And to communicate value, we have to speak the same language. And right now, we don't have a uniform language in the industry to communicate what we're trying to achieve. When you add, say, a solar, say we build double solar for a removable coal plant. Well, that doesn't actually, it's not a 1-for-1. The numbers are double, but it's not a 1-for-1. We can't dispatch that solar. So how do we communicate the value of that? How do we communicate? For example, I was just on the panel session there. It was Natasha Duchesne of National Grid, and she was talking about some line monitoring that they're doing for loading, right? They're checking, and it's like a 1922 line, a very old line. And they were able to get funding because what they did is they started with their renewable demand in New York State and say, okay, you want us to pull this much renewables, we need to have this much more capability with transmission in order to get those renewables to the load. And we don't have dynamic load rating on our lines, and we need the ability to watch these things because they're old lines and we want to push them farther. Well, come to find out, one of the lines was a success. They were able to get 30% more out of it. Other line, they only able to get 10%, and then in some season it was actually minus 30. So, okay, we're still learning with some technologies, but without the driver of starting with kind of the beginning with the end in mind, they weren't able to get that funding. Well, wouldn't it have been nice to say, all right, we have a number of pilots with dynamic load rating, line rating. Here's the typical capability we're able to get out of it, between 10 and 30% more. And here's the value from a resilience standpoint that we can achieve by doing this. I'm not saying it's easy to do, but we need to find a way to communicate so that when we go to make these investments, we get the public, the regulators, the commissioners, depending on what type of investment we're making. We got to get our industry communicating. And I think if we wait for IEEE, if we wait for some of these standards bodies or government bodies to regulate and create a metric, we're all going to be retired. So I think
let's create it right now.
I think we need to create it right now. We need to start the conversation. And that's what you and I are doing, I believe, right now, is having this conversation. And we're continuing the conversation. There are many before us, but we need to get some focus on this, and so that we can communicate and start driving smart investments, because we want to do all these great new things. That's great. Where are you going to get the money from? Well, you got to maintain your existing grid at a lower cost, extend the life so that you can use that money to go and build new, great, exciting things like data centers and generation for data centers and all kinds of sensors and switches and so forth on the grid. How are we going to pay for that? We've got to have a holistic view, and we've got to be able to use resilience measures. And I would say specific reliability metrics like all-in SAIDI or SAIFI, including some of the storm events.
So, I mean, I feel like our discussion can go in many directions. Data-driven decisions, like where are they coming from your space? But really, I would love, just to brainstorm. One is avoided cost, right? I think a lot of us talk about it, right? Avoided cost equals gain capacity. So with smarter And what's smarter? Well, it is smarter. I don't know. Smarter data? It
Better,
can
I would say
prevent.
better information state, right? You get
Right.
more information that's relevant, you're going to make a better decision.
Right. So it's with more information organized and governed, which is a sticky wiggy, right? It will allow you to prevent as humans, because this is all human processes that will be changed on the consistency of that reoccurring measurements. So, like, can you avoid a $2 million substation failure if you had, situational awareness on certain elements that are surrounding that, right? From a more like cascading. And so how do you quantify that for, say, every substation? I'm just hit or missing. But one thing about I guess I was thinking about, we all talk about data, smarter data, a power of it. We can deploy all the LiDAR and all the sensors and all the drones, but having the human intelligence and the capacity to like bring that data back. And I've used this analogy before. Dr. Valentine shared it with me. But think of Home Depot. If all of the material was just thrown into a pile in the middle of a big warehouse, I mean, that some may say is like where our headspace is in regards to the disparate data sets that have now exist inside a utility. And what we're evolving from is like taking that pile of data and then putting it into the aisles and having it all organized in a way that you can retrieve. And then you get a recipe card to say, this is how you build a house. And you can go and get that. And it's clean and repeatable. I think one thing that we don't talk about enough in the utility space is because we did not have to have that data in all of those siloed organizations talking to each other because of the one-way power flow. We kind of built the grid. We understood it, rinse and repeat. We kind of did our thing. Now we're in a space where that has to evolve too. So like we can't just go from zero to nothing. It's going to require an evolution of a utility to take all of your powerful new insight and implement it into the processes that exist in their systems. So how do you quantify that, right? Like, how do you quantify that additional upfront cost to get into a space where you could repeatedly calculate the avoided cost of a certain set of conditions? Or if you can start developing a metric around predictive analytics, right? One other one would be like situational awareness, faster recovery, right? If you know about it happening or it does happening, crews can be dispatched. So there's a lot of, I think, language that we're all using. It'd be lovely to bring it together, is my point, and kind of like put that in buckets.
And I think it needs to be something simple to start. And we need to start somewhere so we can start the conversation and then learn once we start using it informally. Like, we're not requiring utilities to meet it's not a top-down enforced thing. It's really, I see it's a win-win. It's not you will meet this certain metric. It's, you want the public to fund this new transmission line, these upgrades of these towers, to extend the life of these towers. You want to upgrade that, you want to invest in that project. Okay, you want to get the regulator on board. Well, as Judy Chang said, if you're starting to talk about the value of the project when you announce the project, it's already too late. You need to be communicating ahead of time, getting the public, the regulator, even the utility organization on board, educated. We got to close the knowledge gap. And I think a big piece of that is human communication and initially perhaps a simple metric to start saying, quantifying what we're doing so that we can speak the same language, head in the same direction.
For our listeners, what would be an example of a similar pipeline project or a few pilot projects that Osmose has been able to kind of unlock and start championing, by giving them this data, it's driven predictive action, which has saved.
Well, it's the same story for just about every asset you touch. So I'll pick two. One is, we've been known for wood for a long time, so I'll pick two others. So for steel towers, there are a number of utilities that have these steel towers that structurally look sound. You can fly over them with a drone. There may be a couple little issues on top, but a lot of the problem is below ground. So going out and getting that inspection of those underground components, making sure that they're not rusting. Sometimes they're almost completely rusted through. So getting some type of maybe a statistical sample of your towers to say, oh, where are we? But also looking at data, say, okay, that kind of tower and that kind of situation, this is what we've seen in the past. We have a body of data. And then you say, okay, if we're going to say, put new lines on them, maybe they're heavier conductors, can it withstand that? Well, a big part of it has to do with those foundations. Can the foundation or the below ground line steel withstand that? So we've had some success at developing programs using capital life extension of those towers, even without doing the upgrades of the lines, but it would be great if it was. And then we can even model whether, say, for example, we're going to have extreme weather, certain areas we know that we're having category 3, 4 hurricanes, whatever those wind speeds are, be able to model those towers and know that not only the existing structure is going to withstand that, but any upgrades. And perhaps we need to upgrade them even further so they can withstand higher winds for extreme weather. So that's a great opportunity to extend the life and ensure that it's going to survive those extreme events using the data we have on towers. Now, say, for example, on underground with cable systems, we know that underground, say, medium voltage cable systems, people would say, oh, they only last 30 to 40 years. Well, we know that they can last 80, 100 years if we remove the defects and we put over voltage protection. So the extreme events for underground cables are not the winds, they are the extreme voltage surges that come from switching and lightning and so forth, which the switching actually happens almost every day. It sees these disturbances, and that's what advances defects on underground systems. So if we can remove those defects strategically, in some cases it's just repair a couple points, the whole line can be left in the ground. In fact, we have some utilities who took the data that we have on those typical vintages and said, all right, if we can convert 70 to 80% of these lines and leave them in the ground, that is a great opportunity to extend the life without massive investment. Otherwise, one utility was looking at billions of dollars to replace all of that, and they were able to reduce their costs by well over 80%. I think they left 90 something percent of their cables in the ground. So we have the data, we have the methods, we have the technology to identify the issue, the understanding of the failure mechanism. We have the data that can build the business case. And we also have the FERC approved capital life extension solutions that we can put out in an array and say, well, which one do you want? You can have your local contractor install these, or if you need some help, we can help you with specific applications of life extension solutions. So ultimately, it's a data communication, but it's a big data and it's very unwieldy. It's difficult to handle, but with the modern tools, it makes it a lot easier. And ultimately, utilities are able to reduce the costs, remove O&M, right? And use that capital to go do the cool things like putting more sensors on the grid and building out for AI, or even upgrading other assets for extreme weather.
So just to simplify, these technologies you're speaking of is implementing other pieces of hardware or sensors or capabilities to pull back data that has never been available. And why it's becoming more and more available is because the technology to extract, pull, analyze, organize, and then distribute said data to those that need it is becoming more and more available. I think that's like a lost lineage, right? Like this ability to transport and transmit and then analyze and then distribute, has evolved in itself over the last, 10 years in a very exponential way. So we're like we're at a pivot point where there's now all of this new way of doing. And so we have to kind of really inform, embrace, and do. So would you say another, big thing is, and we've kind of mentioned way at the beginning, was, the distribution grid as is, there is this space of run to failure because the assets themselves are so many, and then the cost to prevent or predict, wasn't there. Do you find now with this new increased data sets that you're able to kind of allow or support the utilities to have more of an effective, let's reinforce, let's, replace, and or let's, let it lie based on more intelligence. Is that helping with those buckets?
Absolutely. So, as you mentioned early in the conversation, utilities have a ton of data that they're sitting on that in many cases is so messy, they're not able to use it. So, some great examples is Southern California Edison is now using AI to track events on their primarily overhead distribution grid. Eversource is doing the same thing, different program, but similar ideas, monitoring, say, the transients, the momentary faults, the arcs, the voltage transients, the high spikes of current, and starting to triangulate where those activities coming from. And Eversource just gave a presentation. Well, I think you were there. I can't remember the gentleman's name from Eversource, saying that something like 60 to 70% of the time when they detect certain extreme events, electrical events on their grid, they roll a truck and they're finding the root cause of that. And by that, they're able to start getting ahead of the deterioration of electrical systems. So you combine that with, say, those sophisticated pole inspections and the pole data. Now you have the physical infrastructure tied with what's happening electrically. And then you have the weather data, which is happening, that's the wind load. Now we start piecing these parts of the puzzle together. Now we're getting closer to a digital twin, right? Because it's one thing to have a digital twin and a couple variables, but if you don't have the data that's accurately selected, it's organized, then people that understand what the data is and the machines can learn what that means. And now you have measuring the electrical effects. You start pulling this together, and all of a sudden you start getting way more predictive as what's to happen.
What Ben is talking about is de-siloing data sets. And I think, if any of our listeners, and what I would love is to plant the seed, grid modernization isn't just technical and enabling and unlocking these new gadgets and gizmos. It's fundamentally rooting your organization, your culture, preparing your change management, that if we set up our architecture of where all this data can go, if we then have protocols and understanding of what it means to govern that data, and then we can pipe the data, aka make it talk to each other in ways that yet some of us have yet to realize the power of, but there are an enormous amount of partnerships that can help lead the way to say, you can do, as you said, simple use cases to get you started, and then evolve into this space of data science and model building and AI. And I think let's not lose sight of that evolution, right? Because it will unlock everything that we were talking about, giving the utilities that awareness. And so I think, wrapping it up here a little bit, because I have two questions, it's just we need to acknowledge the asymmetry between the disconnect of what the utilities know internally of themselves and each other and what regulators and customers expect externally. And so there's a lot of internal workshopping that needs to happen to really allow, say, your resources or your partnership to thrive. And so I think just a simple acknowledgement of that and lower the defenses, and then kind of invite curiosity of all of the amazing opportunities if we get the core fundamentals structured and shared.
And that is the opportunity for this next generation that's coming in, right? This what's the statistics, something like 60% of utility employees have less than 10 years of experience. But this new wave of young, excited people who are excited about the grid, they're excited about the energy, the transition to different sources of energy. They're excited about the data aspect of this. And many of them didn't get to learn, say, some of these fundamental physics of the grid, but what an opportunity to start learning by diving into the data area, being able to connect and communicate. So communication, data, and learning is an incredible opportunity for our next generation to help, right? The previous generation doesn't know how to handle this large amount of data and how to use the new tools. what an amazing opportunity for our next generation
And
team
we
to
need like the power of three, like the trio. I don't think we need armies within utilities. We need like this unicorn of a relationship. Your IT data science, like understanding terminology. You need your power systems operations expert, and then you kind of need your economics financial steward, right? That
right.
can really get in there, like understand each other, and then just champion themselves through the organization to unlock these capabilities. So like from anyone seeking to like step into the utility, there's a space for all of this creative thought and creating a culture that welcomes this and then allows them to explore this space, I think would be transformational itself. And a part of that is, one of the first exercises could be creating like a shared language glossary, right? Like when a policy wonk says this, it translates to an operational field op this. And so that people are speaking, to the same ideas and needs instead of a lot of our, what we do, which is very silent. Anyway, it's exciting times. So I'm going to throw one
Right.
question. Oh, go ahead.
Right. No, I was just saying, and I've seen some even recent appointments to executive positions of people who don't have the deep rooted, they weren't a lineman, they weren't an electrical engineer. They came from more of a communications background. And in many there are people that have to know the physics, people that have to know how things work in detail. But a big piece of what we need is to break down those silos. And that's going to require human communication. That's exactly what we were talking about before, about developing metrics so we can have a common base of language. This is, to me, the reoccurring theme is educating, removing the knowledge gap, helping educate, understand why we need to make these investments to really not just within the utility, but the regulators, the public, and all the stakeholders, because it's our grid, right? We all need the grid. And we need it to be strong.
So if you could give a utility leader or an up-and-coming agent one piece of advice when it comes to really assessing the grid and championing this change that we spoke of, what would it be?
I would highly recommend that they pitch the idea if they're a young, just getting started. First of all, learn as much as you can from the people directly around you, but get engaged with industry organizations like AEIC, IEEE, and others. As soon as you can get involved and start asking questions and learning, there's a whole world of very helpful people. You know this industry. People love to provide their experience, their advice, are passionate about it. And if our young people aren't stuck in an office for the first 10 years of their career, I think they're going to do amazing things. On the executive side, I would say you also need to join the conversation. And really, I think we need to push a common language around resilience. I know that Eversource is using, I think, all-in SAIDI is what they call it, including their storm data. We need more innovation like that, and try it out and see if we can't start using those metrics to make better decisions and communicate the value of the investments we want to make, because we're not going to get the funds to do what we want to do if we can't communicate the value.
Love that. So in summary, grid resiliency, isn't it just about surviving the storm, right? It's really withstanding uncertainty, and it comes in all forms.
That's true.
So how do you become comfortable with uncertainty? You lean in, you listen, observe, learn. So
that's right. We remove the knowledge gap and it won't look so scary.
Exactly. Well, thank you, Ben, for coming on today and sharing your wisdom and the work that you're doing at Osmosis and in the industry. I look forward to championing this change with you as we move through it.
Let's do it.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.